Hi, I'm Brenna Book, a developer evangelist at MinIO, and today I'm going to walk you through a demo of AI store tables, which we're really proud and excited to announce is generally available. You know, Organizations adopting Iceberg have historically faced two challenges: the operational complexity of managing an external catalog, particularly on-prem, where it's a lot harder to spin up and manage a Postgres warehouse out of nothing, and security and governance gaps as a result of disparate security models from these separate services. An AI store table solves this by integrating the full Iceberg REST catalog directly within object storage. And the result is a more comprehensive, secure, and simple data lakehouse compared to on-prem alternatives. This marks a really fundamental shift in how organizations may more easily prepare and leverage data for analytics and AI use within their data lakehouse. With AI store tables, Apache Iceberg becomes first-class citizen within AI store itself, inclusive of views and multi-table transactions. This change ensures that customers can consistently and securely store and query more of their data than their stack with a simpler industry standard compliant data lakehouse stack. And this is a significant achievement in both efficiency and cost savings. So I'm going to walk through a demo of AI store tables using an example use case of an IT asset management AI agent. So think of a company that needs to track hardware, inventory, software licenses, and all the documentation that goes with them: manuals, invoices, support tickets, configuration guides. The business needs to know things like which assets have an expiring warranty, which servers are running in our New York City data center, which software licenses need renewal, and importantly, can an AI agent help answer these questions by pulling the right documentation automatically? And this is a perfect example of how structured metadata in Iceberg tables can point to unstructured data or documents in object storage. And this is a pattern that makes AI agents actually useful within a modern ecosystem. So we're going to do a setup, an installation. So this notebook is using PyIceberg, but the AIStor tables works with any Iceberg REST catalog API supported compute, Spark, Trino, Dremio, whatever your flavor, it'll just work. We're going to start with by connecting MinIO AIStor's built-in Iceberg REST catalog. There's no separate catalog service needed. It runs on AI store node and inherits all of the durability of AI store. And I want you to notice that we're not spinning up a separate Hive metastore or a Postgres database. The Iceberg catalog is built directly into AI store. And this is that operational simplification that I mentioned earlier. That's just one less thing to manage, scale, and secure. So to make sure we install all our libraries that we'll be using, and we'll connect to MinIO. So we're using 6v4 authentication, which is the same as Amazon's authentication for their version of the embedded Iceberg REST catalog S3 tables. And the same credentials will work for both your catalog API and your data access, your regular AI store buckets. So we're going to create a warehouse first. So warehouses are the top level bucket in AI store tables. Namespaces underneath organize tables, things like schemas in a database. We're going to create a IT asset namespace and an asset management warehouse. So we'll start with the warehouse first. We've defined the name of it up here, and we're going to create it. So this 409 arrow just means that it already exists, which I already know because I've run this one before. Then we're going to initialize the catalog. And we're going to create that asset management namespace here. So just a key point I want to know as we go on that schema has two types of columns. It has structured metadata, which is the asset ID type, manufacturer location, status, and dates, and it has S3 pointer locations. So these are the absolute paths to actual documents, manuals, invoices, and tickets and configs. Now, I hard coded for the demo the actual paths in the S3 path, but in an actual production version of this, you'd probably have a vector database store the locations of these documents as vectors. But for the purposes of this demo, we'll imagine that these absolute paths are vectors. So we can list all the namespaces that we've created so far. We've created quite a few, and you can see everything that we've made. And we'll go into what I was saying about the schema here. So we've got these regular, normal, comfortable, database familiar field, and then we've got these absolute paths here. So we're going to make this table called hardware assets. And that's done. And again, we can also list all the tables within a single namespace. So we can see all the ones we've made. Certainly made this one and the hardware assets that we've just decided to make. So this is the sort of the magic for AI agents. We can store queryable metadata, these absolute paths in this case, or in a production version of these vectors, alongside the structured iceberg fields. This creates a situation in which the AI agent doesn't need to scan millions and millions of files. It can query the metadata first, the iceberg table. It gets a handful of these S3 passes vectors and then fetches only those specific or related documents. So think of it like a library card catalog. You don't have to walk through every aisle looking for books about networking. You can just look up the subject in the catalog and get the exact shelf locations. So, one more thing, I know we've already discussed this, but I want to re-emphasize the interoperability of AIStor tables. So when I say query engine, I want to indicate that AIStor is completely query engine agnostic. The Iceberg REST catalog works with any popular query engines, Spark, Trino, Presto, Flink, Dremio, Snowflake, Databricks, what have you. And because we're using the Iceberg open table format, it can recognize and work with pretty much any file or table format that you're already using or familiar with. Things like Parquet, Orc, Avro, it will all just work. You're not blocked to any specific ecosystem or any specific file or data table format. So we're going to load these. Next step is we're going to load all these um, values into our table. We're going to load these laptop, these network equipment, and then we're going to pretend we're AI agents. Now, this scenario will work whether or not you're an actual human being or an AI agent. But you can imagine if you like that you are a human being or not, depending on your feeling for the day. So we're loading three types of assets here: servers, laptops, network equipment, as you've already seen. And each record has a realistic metadata, the table information, plus those absolute S3 document paths. And in production, like I said, these would be vectors that point at real PDFs, configs, manuals, however you want to do it. Um, So some quick data highlights. There are servers are in two data centers, New York DC1 and San Francisco DC2. There are two different manufacturers, sorry, four, Dell, HP, Lenovo, Cisco, and there's a mix of statuses, active, maintenance, retired, supposed to be realistic warranty dates spanning from 2024 to 2027. So now we're pretending we're either an agent or a human being. So you're going to imagine that you have, or it has, productivity alerts. It's got five assets with warranties expiring in the next 6 months. Here are the invoices to check renewal pricing. And that's this query. So run that and see what it says. We get a fetch of two assets with expiring warranties. So you can filter by date, status, all in one query. You can return, it returns the absolute document paths, which allows for immediate action on these expiring warranties. There's no scanning a huge bucket. Iceberg makes this fast. So let's say there's another pattern where you're planning a maintenance window in uh, New York City, DC1. You maybe can ask an agent what's running there and give me all the config guides. One query with an instant answer. You can see what's running and where it is. So let's look at another one. This is bad news. This is when something's broken. You want the history. This query finds everything under maintenance and retrieves the support tickets and history so that the agent can summarize. This server has 3 memory failures in the past year by checking these manuals. Or maybe we want a situation where a new engineer joins the ML infrastructure team and asks, what servers do we on? The agent can immediately answer this with links to all the relevant documentation. I'm getting the point here as we go on. These are all situations in which an AI agent or a human being can request information, iceberg structured data, alongside unstructured data like manuals, PDFs, videos. I can go on and on. There's a few here. Do you want to show off one more interesting feature of AI store tables that will be included in the general availability of AI store tables, which is views. So this wasn't originally in AWS's implementation of a similar feature called S3 tables. They don't offer support for views. And with our implementation, we'll be the first on-prem object store to implement the complete catalog, including views. The reason why this is so interesting, especially for lake houses, I mean, this is all icebergs, this is all lake houses, but it really supports the pillar of the lake house ideology, which is interoperability. So this means that you can create a view with Spark or PySpark, and that view, barring syntax issues, will be available to other SQL or query engines, which means we get away with a situation where views are stored in proprietary formats that are only available within one specific engine. So, for example, if your sales team uses, I don't know, MySQL, but your HR team uses Dremio, there's no problem. You can share views across these engines, which is, I think, a really big win for lake houses in general and interoperability in specific. So I'm going to show you what that looks like. We're going to create a view with this little helper process down here. So we're going to create this view. So this is a view that pre-filters assets that require immediate attention from an agent or a human being. Their expiring warranties, their maintenance issues, servers and products that have retired. So it allows a view or the actual SQL query part of your AI agent or human being response to be saved across engines within your storage, right next to the tables. So we're going to create this other view, which is just a quick summary of the servers by data center location. Perhaps this is a query that gets requested quite a lot, and we'll do another one, which is license renewal dashboard. So perhaps this is for your BI tool that needs frequent refreshes of this data so you can show all the license renewals that are available. And now we can see all the views that we have on deck, which is quite a lot. And we can load the metadata about the views. So this things like what their schemas are, what this query is specifically, properties about it, can get more information about what it looks like. And we can also view the table metadata, which again is that whole query, the location, things like what columns will be generated by this query. You can look at the snapshot. So these are all of the times that that query has been run and the results of that. This is really interesting because you could roll back or look at past versions of this query, which can be really important in case of an outage or a data corruptibility issue. You can create a partition table by location. So now we're moving away from views and into other advanced features of the Iceberg REST catalog. We'll run that and we'll see you created a partition, which means every time you take a look at this table, it'll run much faster than its unpartitioned version. And of course, you can do everything you can do with the Iceberg REST catalog, including cleanup and things like that. So really exciting services. This is a complete integration of the Iceberg REST Catalog API. And we're really excited to launch its general availability. Um, I hope you have a chance to play around with it and to implement it into your lakehouse. If you have any questions, as always, please reach out to us. Thank you so much for joining me on this demo.